Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 9 of algorithms in Swift. Oops, I've almost lost all my fingers here, but day 9, okay, officially. Um, Today is a rather interesting problem. I cracked this problem out of my vault of very, very difficult problems that I think could really test one's ability to think. This problem involves you being able to predict an accurate number that the user passes in without using a divide and conquer technique. Okay, so divide and conquer is a very efficient and a very efficient way to chop arrays up and chop large collection types up to try to find specific indexes. Today, we're not going to be able to use that. I'm not allowing you to use that. I want us to think of a different way, a more creative approach to solving a problem like this. So, without further ado, here we are. Let's start. So our problem states, write a function that accurately detects and returns any number the user passes in without using a divide and conquer technique. The number could be any number from 0 to 18 quintillion. Wow, Kevin, that's a large number. I'll explain that in a second. So, sample test cases, the number 100 should return 100. The number 9 quintillion, something something 808, should return the same number, 9 quintillion, something something 808. The number 9 quintillion, same number, something something 808, should not return 9 quintillion, something something 807. The number 18 quintillion should return 18 quintillion. Okay, so why am I using such large numbers? I'll explain. This is to test the interviewee's distinction and knowledge of the distinction between large numbers, integers, and unsigned integers. Okay, so the maximum value of an integer, the highest it can go, is in fact 9 quintillion 807. This number right here. Okay. Um, So integers have a range of negative 9 quintillion 807 to positive 9 quintillion 807. Okay, so this number purposely goes over it to test your ability of using a larger number like an unsigned integer rather than an integer to solve this problem. Because if you use an integer and pass it in, you're going to get an error like this, where it will tell you that you are overflowing. Integer literal overflows when stored in its end. It can't hold that much memory. It doesn't have enough memory to hold that. So what you will use, or what you should use to solve this problem, given this range, is an unsigned integer. An unsigned integer maximum value is equal to this. I'm going to show you really quickly. You can see it for yourself. This returns true because this is the maximum value of an unsigned integer. Okay, so I'm literally having you solve this problem for any number the user passes in that's between 0 and 18 quintillion. Okay, so let's begin right now. We're gonna not use a divide and conquer technique. We're gonna use what I call the bike locker technique. Okay, like this bike locker, and we're gonna go through each number, individual number, in the number that's passed in, and we're going to ask if it's equal to 0. If it's equal to 0, great. If it's not, we're going to add 1 to it. If it's equal to 1, we're gonna pass on to the next number. If it's not equal to 1, we're going to keep adding 1 to it and see if it's equal to that number. So it'll be 2, 3, 4, 5, 6, 7. The beauty of that of this process is that if every individual number in a number is within the range of 0 to 9. Okay, so if we ask if it's equal to 0 and it's not, we just keep adding 1 to it until it's equal to a number between 0 to 9. Okay, and if that doesn't make sense to you, it's going to make sense to you when I write this function. Okay, so at least I hope so. Okay, so number predictor, number detector. I'm going to pass in an unsigned int. I want to pass in, we're going to return a string. Then we're going to call this a numbered array. We're going to put this string, put this number, our unsigned int in the numbered array. Then we're going to get the numbered array count. That's going to be then index is going to be equal to 0. counter is going to be equal to 0, and then our final string is going to be a variable. Okay, I'm just going to change this. I'm going to change a couple of these constants because we're not changing the variable, and this is just to save more space in memory. Okay, it's more responsible coding. Okay, so for this and 0 integer dot max, I ask if I want to convert numbered array to a string. Okay, 0 plus index. If that's equal to counter, then we're going to append. Convert to Swiss string. We're going to append string character string counter to our array. Okay. Then we're going to reset index. Oh, we're going to add 1 to index. Sorry. And then we're going to reset counter to be equal to 0. And then we're going to write an if statement if index is equal to count, which is the maximum, which is the array count, then exit the function immediately and return the final string, whatever that is. Okay? So this is if we find a match. If we don't find a match, we're just going to keep adding 1 to our counter. Simple. Okay? And then to satisfy this function's requirements, we're going to return the final string. Okay? So basically, this goes through every individual number in the string, and it asks if it's equal to whatever the value is for counter. Counter starts at 0. If, let's say we're doing number 123, okay? If it goes to the first number, it asks if it's equal to 0. If it's not equal to 0, it's going to add 1 to it, and then go to the loop and ask it again. Are you equal to 1? If it's equal to 1, then it appends that number to the string, and then adds puts counter at 0, and then goes through the loop again. And so we get to number 2. Are you equal to 0? No. Are you equal to 1? No. Are you equal to 2? Yes. Okay. Then it goes through it again. So it's sort of a brute force, but sort of creative approach to solving this because it's efficient. Okay. So I'm going to show you how efficient it is. Just do a loop counter right here. Okay, and then we're going to run our function number detector. Oh, sorry. We're going to pass this in right here. And this should return our number. Yep. And you see that we only went through this loop 108 times with the with 9 quintillion 808 or whatever, however you say that number. Okay. If we go to the 18 quintillion, we're going to get 107 times it goes through the loop. So that's efficient because one, this is correct. This is a correct solution to the problem. But also, it's not as horrible as going from 0 to 18 quintillion, doing this for loop 18 quintillion times to find a number. If it's worst case scenario, 18 quintillion, something 14 perhaps, right? Or the maximum value. We only go through this loop 107 times with the maximum value of an undecided integer. So, sorry. So this works. Guys, let me know what you think of this problem, the solution. This is a pretty tasking challenge, and it definitely encourages some creativity to solve it. Please let me know what you think. Hopefully this helps you in the interview process. My name is Kevin Tarr. Happy Mother's Day to everybody today that's watching, and have a blessed day. Bye.